On the last video, we left off talking about probability and how we describe it using numbers. And exactly what we do is we describe it using from 0 to 1, which would be the likelihood of something happening. So we could say a 0.5 chance, but many times we talk about that as percentages, like 50%. 1 is 100%. We use words to describe probabilities also. What's the chances of it raining tomorrow? 50-50. Impossible. It's certain. Those are some of the terminology we use. So thinking about this here, the event is nearly impossible. We would say that's a 0% chance. Estimate this probability, right? That matches the following statements. This event will occur often, but it's not extremely likely. So maybe somewhere between a 40% and 70% chance, somewhere there. And again, it's still a little bit subjective what the answer is. The event will occur for sure, and that's 100%. So just be aware of how we describe probabilities. Probabilities, the likelihood of something occurring, and we use percents, but it's actually a number between 0 and 1, and those get converted to percents. Let's talk some more about this. Now, when we talk about probability, especially in this class, and then when you go on statistics, we talk about there are two types. One is called theoretical or classical, and the other one is empirical, also known as observational. So we'll start with theoretical. This is what you commonly know about probabilities. These are, we talk about theoretical probability with games of chance, flipping coins. We know the outcomes ahead of time already. Rolling dice, spinning spinners, if you're a gambler, roulette wheels, lotteries. They are theoretical because these values are determined by the design of the game or the design of the object, the coin we're flipping. So we can calculate theoretical probabilities here. You can see probability of getting ahead. So we use this capital P to stand for the probability of something happening is 1/2 or 50%. We might have even said 0.5. Probably you roll a die and it's a 3, 1 out of 6. You convert that to decimal, you get 0.167 or 16%. Try that on your calculator so you can get 1 divided by 6, see what you get, and that turns into 16.7%. And here are some other probabilities. What's the probability of landing on blue? 2 out of 5 or 40%. If you want to try an extra one, green, 1 out of 5 or 20%. Again, where am I getting these numbers? Turn these into decimals and then you can see where the percent comes from. And so that's the theoretical probability. And now we have another type of probability called empirical probability. It involves the calculation of the relative frequency, how often something happens. And it's through observation that we can estimate the probability of some event, given up how many times it's occurred in the past, divided by the number of what we call repetitions. The probability of A is estimated by the ratio of the number of times A occurs to the number of repetitions. This is called the relative frequency of the event, or the empirical probability. And so looking at something like this here, we could take a look in each game. In each of these games below, use the results of the experiment to calculate the stated empirical probability. Let's say you flip a coin 10 times and the heads shows up twice. So if someone asked you, what's the probability of getting the heads? You would say 2 out of 10 because it happened twice, right? Out of 10 times, 2 out of 10. You roll a die 25 times, 3 comes up 5 times, so you would say 5 out of 25. We're using empirical or observations, right, in terms of what has happened in the past to determine our probability of the future. And that's through observations. And then this one here would be 7 out of 20. And so this is an empirical probability because we're using observations to determine that, because we didn't have a picture of we don't know what the spinner looks like. So that's why we're using empirical probabilities. We won't get a chance to do this little activity here, but I want to get to one more problem here, which would be these last two here. And again, we're looking at this last problem here, thinking about what the answer would be. You can see here are the number of babies out of how many births are born. And so determine the probability of randomly selected birth results in a baby being born with O blood. And you can see it will be this number divided as total over a 45% chance. Again, this is just through observation. So that's your part 2 of your probability, theoretical and empirical probabilities. You have this for your next discussion section here, these problems here to complete.